Hi, grade 7. It's Mr. V again, and I'll be teaching some more math. Today what we're going to do is get a chance to look at some equivalent ratios. So our goal is just to explore equivalent ratios. We'll look a little more in depth at them during the practice time, during class, but that's what we're going to get to do. Our problem that we're going to be looking at today is that Fawn drew a red rectangle like the one below, I'll show it to you in just a second, on some grid paper. And she wants to create a series of what's called similar triangles. Now, similar triangles, I highlighted it because you need to know that definition, but similar triangles are rectangles that have the same shape, but not necessarily the same size. So, here is our main question. So how do you draw similar rectangles? Now, if you notice, we have a rectangle here that is 2 centimeters, which is the width, and 3 centimeters, which is the length. I decided to color it in red. Then what I decided to do was to start a line in the bottom left corner of the rectangle and extend it through the top right corner, and then I just kind of kept going on and on until I got a rectangle that was 12 by 18. Okay? And what I'm going to be doing, and I did one already, is every time I'm going to draw a new triangle, because the goal is to draw similar triangles, every time I do one, I'm going to be adding 2 on to this side, and then be adding 3 on to this side. And my goal is that I will hopefully end up with 5 similar triangles. Okay? I have my trusty ruler out, and what's going to happen is I'll just make little marks every 2 centimeters, and then every 3 centimeters this way, down the bottom. Okay? And so basically what's going to happen is that I'm just going to draw a line here until I hit the diagonal line. Okay, I know this upside down. Okay, so here I've added 2 on to the width, and I've added 3 on to the length, and my 2 lines meet on the diagonal line. That's very much on purpose, very much. Okay, I'm going to add 2 more onto the width, and I've added 3 more onto the length, and again notice that the lines meet at the diagonal, also still very intentional. Okay, and lastly add 3 on to the length, and then 2 more onto the width. Okay, so I now have 1, 2, 3, 4, 5, and then 6 overall rectangles. Okay, now what I'm going to do is I'm going to start filling in this chart. Now, we talked last time about how to write ratios, and the first rectangle that I drew on is 2 centimeters for the width and then 3 centimeters for the length. As our ratio is written here, width to length, the way I'm going to write that is 2 to 3. Okay? My second rectangle, if I start at the base and go up, that's 4 centimeters for the width, and then it's 6 centimeters for the length. And so my ratio becomes 4 to 6, 4:6, a little hard to see. There we go, 4:6. My third one is 6 centimeters for the width, and that's 9 centimeters for the length, which makes it 6 to 9. My fourth one goes up to 4, 6, 8 centimeters, and it goes out 3, 6, 9, 12 centimeters. And so I write 8 to 12. My fifth one goes up 10 and out 15. So it's 10:15. My last one, the one up here is, sorry, a little hard to see. The last one, the big one up here, goes out 12 centimeters and across, or the length would be 18 centimeters. So it's 12:18. Okay? And so this is the chart that I'm working with of my rectangles that I've drawn, and these are the ratios: 2 to 3, and then 4 to 6, and 6 to 9, and 8 to 12, and 10 to 15, and 12 to 18. We call these similar rectangles. They're all similar. Okay, you can call these equivalent ratios. Okay, and what I'm going to do is I'm going to have another diagram over here. I'm just going to move that away for a second. I have another diagram. It's the same one that I originally started with. It's the red 2x3 rectangle at the bottom, diagonal line drawn across. What I'm going to do is I'm actually going to add 3 to each time, to the length and the width. So what I'm going to do is I'm going to make those lines meet up. I'll use my red pen. Okay, and so this is what I end up with. I have a dot here I can't even connect because this doesn't go up quite high enough. It was a 1, 2, well, I could actually, it goes way up to there. And so these are the rectangles. Oh, it's even hard to draw. These are the rectangles that are drawn by adding 3 on every time to the width and to the length. Okay? And what we have for the second group, the first one here, the width is 2, the length is 3, the ratio here is 2 to 3. For the second one, the length is 6, the width is 5, and so the ratio is 5 to 6. For the third one, the width is 1, 2, 3, 4, 5, 6, 7, 8, and the length is 9, so it's 8 to 9. And then I'm only going to get to the fourth one. I don't even have enough paper here to get to the fifth and sixth one. But if I'm going up by 3, the next one here is 11, and this one goes up by 3, it's 12. So that becomes 11 to 12. Okay, this one would be 14, and this one would be 15, and so that's 14 to 15. And then lastly, it goes up by 3, so that's 17, and then by 3 is 18, so it's 17 to 18 is my ratio. So I read a little hard to see on there, but it's 17 to 18. So I end up with a bunch of these different ratios here that don't really work. Well, they work, they're ratios, but they're not equivalent ratios. They don't represent, they're not equivalent, they're not similar rectangles. They don't show rectangles that are the same shape. They're definitely different sizes. They don't show them as the same shape. And so there's some questions here that we'll just talk about really quickly. But which groups of rectangles contain similar rectangles, and how do you know? Well, the ones that meet up with the top right corner meets up with the diagonal line that we drew. Those are the ones that we know are going to show the same, have the same shape as our original rectangle. Okay? And which groups of rectangles are the ratios of width to length equivalent? It's the first one. What is the connection between ratios of sides and whether rectangles are similar? They have to go up in the same proportion. They have to go up in equivalent blocks. So if you start with a length that's 2, you have to add 2 every time. If you start with a width that's 3, you have to add 3 every time. So basically, you need to understand the idea of multiples to get similar or get equivalent ratios. Okay? Did the diagonal pass through each rectangle in the top right corner in the second group of rectangles? No, it does not, because we're not adding 2 every time. It works along the length, but not along the width, because we're adding too much each time. Now, the last question there, if you start with any rectangle, how can you create rectangles that are similar to it? Same strategy. You draw a diagonal line from the bottom left into the top right, or bottom right to top left, and just make the your two lines of the rectangle meet. And I'll show you this one again. You make them meet at the diagonal line. Okay? That's how you show that they are similar rectangles. Okay? That's how to do that. So we can find some equivalent ratios by using this sort of idea. Okay? And what we can do is we can just say, well, if I double this one, that becomes 2. And if I double the second number, that becomes 4. Okay, if I triple it, it's 3. Triple that, it's 6. If I make it 4 times as big, it's 4 over 8. So those are all equivalent ratios. Let me change color. Those are all equivalent ratios to 1 over 2. Now to 9 over 12, to find some equivalent ratios. What I can do is if I double the size, that becomes 18 to 24. If I triple the size, it becomes 27 over 36. If I make it smaller, because I can do that as well, if I make this original one smaller by a third, that gets me down to 3, and then over 4. Okay, that's also equivalent to 9 over 12. And then lastly here, I can do the same thing. I can simplify this down. 6 over 8, it becomes 3, it becomes 3 and then 4. And I can find some other equivalent ones. If I triple the size, it becomes 9 over 12. If I quadruple the size, it's 12 over 16. Those are all equivalent ratios.